Hello everyone, welcome to this session. In the previous sessions, we have already introduced the knowledge of SVM, and from this session, we will introduce the implementation of SVM. So the built-in function in MATLAB for SVM is this one, feed_c SVM. So this one implements the linear and nonlinear SVM. So this function is quite a complex function. So we have many input arguments, but we don't need to know all of them. So here I provide the most frequently used code to train an SVM classifier. So we can see this is the object, the feed_c SVM, x, y. So x is a feature and y is the label of the training data. The second one, the kernel function. So kernel function is what we have just discussed, right? So it can be linear, can be polynomial, can be the RBF or sigmoid to transfer from a low dimensional to high dimensional. So box constraint. So what is box constraint? I think you may remember that the C, right? The C to penalize the misclassification, right? So that is a box constraint. Now this one trades off the misclassification and the width of the margin. So the larger width, more misclassification, right? But more generalization ability, right? So this is a box constraint, the C value. Standardized, I think you also remember this. We have discussed in the data preparation course, right? So in that week, we normalize the data, or we standardize the data and to make it Gaussian distributed. So we can see the standardization, right? So then we will do the training of the SVM. So we call this function, including all the input. So here we can see I use a linear kernel and the box constraint, the C value is set to 2, and I do the standardization. The output, this one, I wrote SVM here, and you can write other names. So this is an object. The type is called a classification SVM. So this is a trained SVM classifier. Already the trained SVM is saved here. So it have the support vectors, all the other parameters, right? So if you want to visit this, you can use the dot method to get access to that. So for example, this is an object. I can say dot support vectors. So it will tell me which are the support vectors. And beta, SVM dot beta. So this will give me the coefficients of the linear classifier. So this is the W, right? And this bias, this is a B, right? So if we can see here, we classify these two classes, and the hyperplane is a W transpose multiply X plus B equals to 0. And the W is a beta and B is a bias. So this is a fit SVM input and output. So after we train the SVM classifier, we need to make the prediction, right? So we can use a trained classifier and the test data and use a predict function. So the predict function is here, SVM, comma, X underscore X test, right? So this one we can see the X test is features of the test data set. So this is a trained classifier. Then we get the output, we got a Y-pred. The Y-pred, this has the same data type as a Y-tree, right? And the length is the same as X-test. So it will tell us that using this trained SVM, what are these features, the classes of these features in the Y-pred, right? So you can see the live script for more details. So knowing this function, we can use iris flower classification that we have shown for a few times. So using these as features, these are the labels, 150 data. Then we can see how to train the SVM and use this to predict something. So you can try yourself. Okay, thank you very much. Bye-bye.